Welcome back. So we were calculating the cost of number of visits to the Six Flags, and we said the independent variable is number of visits and the dependent variable is the cost, because the cost depends on the number of visits. We also wrote this equation as a function notation. So C of V is equal to 69.99 plus 10V. And sorry about the handwriting, it's not easy to write with a mouse. Moving on, we also were able to calculate the cost of two visits. The cost of two visits was were $89.99, and the cost of four visits were $110. The cost of two visits was $90, and the cost of a zero visit was $69.99, because I guess you just purchased the Six Flags season pass and never actually went to the park. That would be a bummer. So in this video we're going to make a table using the values from previous page, and then we're going to graph the function. We're also going to label our x-axis and use an appropriate scale. When creating a graph, we just got to make sure we have a title for the graph. We're going to make sure we label our x-axis and y-axis. We also got to make sure we use appropriate scale. And I'll talk more about what it means to have appropriate scale. But first, we need some data points. We could create more, but I think having 4 data points is good enough for a graph. And we're going to get these data points from our previous page. So C is the number of visits, and the cost was in dollars. So if you go back, let's go back to the previous page. We know the cost of 2 visits is $89.99. We're actually going to round to $90, and actually example A and C, looking back, is actually the same example in different terms. The cost of 2 visits is $89.99, and again the cost of 2 visits is $90, which is only a penny off because of rounding. So we only have 3 different data points. For 2 visits, it's $90. We're going to use whole number because we're graphing. For 0, we'll round it to 70. So that's a 1-order pair. So we will say, let's see. We can write this as an order pair. We could say 0, 70. Okay. Here it would be 4, 110, and here it would be 2, 90. Just remember those order pairs. So 0, 70, 2, 90, and 4, 110. Okay, we're going to put those order pair, our data points, in a table. So 0, 70 is 2, 90. And for 4 visits, 110. We should probably calculate one more data point. So let's pick 6 visits, and if you follow the pattern, each visit is $10 more. So adding 2 more visits would be 130. Okay. We don't really need to do the math on the other page. We could actually continue. We could even do 8 visits and then 10 visits if you want. But I don't think we need to graph all those visits. So add 2 more, so it'll be 150 and 170. Okay. Is the function increasing or decreasing? You can look at the table and see if the values are increasing. We'll also be able to look at the graph and see if the graph is increasing from left to right. And then will the x value ever stop? So this is the x value. Is there a limit to number of visits? I guess there is, right? I mean, if you visit every day for the whole year, assuming it's a whole year season pass, I think 365 days is the max. That's it. So let's graph we need a title for this graph. You can't go wrong with a title, so anything that's appropriate would be fine. I'm gonna pick a title that says the cost of season pass to Six Flags. Actually, I'll choose the cost per number of visits to Six Flags. I'm gonna label the x-axis with the number of visits, and I'm gonna label the y-axis with the cost in dollars. So now we need an appropriate scale. So on our x-axis, we need to label visits. Our visit ranges from 0 to 10. Look at our columns. We have 1, 2, 3, 4, 5, 6, 7, 8 columns. So we could go by 1, but then we won't have enough for 10 if you really want to plot all those 10 points. So we could go by 2. Let's go by 2. So this is what I'm talking about scale. You're going to have to sort of decide what number to go by. So we're going to go by 2. Okay, so that's 2, 4, 6, 8, and 10. Okay, so that is fine. We're using more than 50% of our graph. You want to use about 80 to 90% of your graph. If you look at the rows, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 rows. Our value goes up to 170. And they're all okay. So let's see. We can't go by 10. So maybe we should go by 20. You know what? I'm gonna start at 70. So this is what we'll do. We're gonna break our graph. Okay. This indicates that we're not gonna start at 0. We're gonna start at 70. Okay. And I guess let's see if we can go by 10. So we do have enough room to go by 10. We're going to skip by 10. So that's our scale. If you notice our x-axis, we're skipping by 2. So we're going by 2. And our y-axis, we're going to go by 10. So 70, 80, 90, 100, and so on. Okay. So let's start plotting our points. Our first point is 0, 70. So I'm going to use a different color. So that's 0 and 70. For 0 visits, the cost is $70. Then we have 2, 90. Okay. Then we know it's going by 20, so the slope is rise over run. We go up 2 over 1, up 2 over 1 in this case. So for 4 visits, $110, up 2 over 1. For 6 visits, it's 130. See? So let's go up 2 over 1. For 8 visits, 150. And for 10 visits, 170. And we have a perfect linear graph, so that's good. So if you had a ruler, you would take your ruler and connect the points, and it would be a perfect linear line. And there you go, that's our graph. Okay, now if you look at our graph, is the function increasing or decreasing? Well, you could see that the line is increasing from left to right, so that's increasing. Yep, so the graph is increasing, and the x value, like again we said that if the season pass is good for 1 year, then assuming you go to the Six Flags every day, which is kind of weird, but let's say you do, then the maximum x value is 365, right? Okay. So that's our graph. took us some time, but it does look good. Again, we have our title for the graph. We'll label our x-axis. We use the scale, appropriate scale. We label our y-axis, and again we use appropriate scale in our table. I hope this was helpful, and you should be able to do the next example on your own.